In this next segment, Captain Orion discusses how Newton's laws of motion impact a flying helicopter. He also demonstrates how a toy can be used to make an engineering instrument that stabilizes a helicopter. Lastly, listen to find out how engineering can support the survivability of helicopter pilots.
Helicopters are what we call inherently unstable. Because as the helicopter got bigger and bigger, there's all kinds of funny forces that's working on this helicopter. And we're going to go ahead and demonstrate by using this helicopter. This helicopter is a gyroscopically controlled helicopter. So as the helicopter got bigger and bigger, the helicopter pilot came to us and said, "Hey, Mr. Engineer, we need help being able to fly this bigger helicopter. What can you do for us?" And we said, "Not a problem. What we're going to do is we're going to go out to Toys R Us and we're going to buy you a top to help you fly the helicopter." He said, "Say what? What are you going to do?" I said, "Yeah, we're going to buy you a top. What we're going to do is we're going to go ahead and get that top, and then, how does that work? That top, right? Who was that guy who said something about, things that goes in motion doesn't stay in motion? Fig Newton? Isaac Newton, yes, Isaac Newton said that, huh? Okay, so he says things that goes into motion tend to stay in motion unless reacted upon by some other kinds of outside force. So this gyroscope, when we get this going around and round, well, when we have it going kind of slow, it tends to be unstable. But as it gains speed, as it gains RPM, and we have it going around faster and faster and faster, that's pretty stable. So what we can do is we can tap off of this stability, how stable this is, and we can go ahead and put those controls into the helicopters to make us, fly that helicopter so that even when the helicopter pilot takes his hands off the control, it flies very, very stable. So what we did is we took this top, we miniaturized it. Oh, there's that word again, right? Miniaturized it. So we made it very small, we miniaturized it, and then we made it into an engineering instrument, very high quality engineering instrument, so we can spin it at hundreds of thousands of RPM, revolution per minute. And then we called it a gyroscope. And then we put that gyroscope into the helicopter to help us fly it. This helicopter right here is a gyroscopically stabilized helicopter. And it's very near and dear to my heart because when I graduated from college, this is the first job I had. I actually got to go out there and help design this helicopter. Back almost 25 years ago, when this helicopter was in the flight test program, we got to take it out there and we got to go out there and do almost all these aerobatic types of maneuvers. And this helicopter has all kinds of machine guns underneath and rocket underneath the wing pods here that can be guided, self-guided. We have all kinds of survivability, because, and we're going to talk about survivability some more because it's a whole new area of engineering. Because we spent so much money to be able to train our helicopter pilots. Well, when something happens to a helicopter, we want that helicopter pilot to survive, So survivability, what do we do? Well, with the helicopter, it has a very unique feature, right? We have the rotor blade on top. Well, if something happens and the and the pilot bails out, it's not so good because he goes right into the helicopter blade, and that's not a good thing to do. So the first thing we need to do, when the helicopter pilot is in there and he punches that eject button, wants to get out of there, first thing that happens is we have a shape charge on the main shaft of this helicopter, and that shape charge cuts that blade away from the helicopter, and the blade goes flying off. The second thing that happens is the canopy. There's shape charges in there that blows the canopy away. Third thing that happens is that there's rocket motors underneath the seat of the helicopter pilot and the gunner as well, and it'll shoot him right out of the helicopter so that the helicopter pilot is away from the helicopter before anything can happen to him. And that happens in a matter of split seconds. So that's why they say, hey, if I pull this helicopter, if I pull this eject button, be ready because everything's going to happen just like that. Those three things that I just told you about, it's going to happen right now, and he's going to be out of there. So we're going to go ahead and fly this helicopter. Remember, I said that this is a gyroscopically stabilized helicopter. So we're going to see about how stable this helicopter is. And what's really cool is this. I went ahead and modified this helicopter so these missile pods that's underneath, these missiles underneath the wing pods here, I can actually fire those missiles. And I can actually go and pop this balloon that my wife Janet is going to be holding. Oh, are you ready with the target, Janet? She is so brave because she's going to hang on to that balloon and I'm going to pop that balloon with that missile. I have not missed yet. And as proof, she's still married to me because first time that I miss and hit her, that'll probably be the end. So I have incentive, right, to make sure that that missile will hit that balloon. Okay, so this is gyroscopically controlled, remember? Okay, let's see how well this works. Yeah, so it's pretty stable, huh? It can even go backwards and forward. Yeah, so with this helicopter, we have a gunner in the front, pilot in the back. Right? The only thing that the gunner is responsible for is to take care of the weapon system on board that helicopter because it has all kinds. It has machine guns in the front. It has 16 Hellfire missiles that it can go ahead and carry as well. No, not yet. Okay, so enough about messing this around. We're going to go ahead and fire that missile. Okay, Maverick. Maverick is the pilot. Yes, Goose is the gunner. Okay, we're going to go ahead and laser designate that balloon out there. Make that run. He sees the target. He's making a run. Fire! Wow! How was that for accuracy? Whoa, is that cool or what? Yeah. Can you guys feel that pressure differential working, keeping that helicopter flying? Yeah, you can feel all that air molecule, huh, as it flies over you? Okay, come back to Daddy. Come on back. Okay, come back to Daddy. Yeah. Yes, at least for another week. Thank you.